Hey class, this is Mr. Schmidt for the November, November 10th lesson on choosing a coordinate system and solving for friction. Okay. So the goal for today, by the way, is we're going to be getting ready for this assignment, friction, and we'll also be able to select a coordinate system to minimize the algebra required for this. Still going to be a significant amount, but hopefully we can pare it down some. Okay, so the first question I asked was, let's say we have an object sitting on a horizontal surface. There's a horizontal force being applied. You have the normal force equal and opposite to the force of gravity. We ultimately want to find mu, the coefficient of friction. In order to do that, we need the force of friction. And side note, we're going to have to know mass to solve for these. So the question is, how do we do that? In class, I took a break and you guys worked on that. On the video here, we can jump straight ahead to the answer. Okay, so we have these three things here. So like I said, our ultimate question is, how do we solve for mu, the coefficient of friction? Well, there's only one equation that has that, and that involves the force of friction. So we know at some point we're going to have to use this equation. Well, in order to solve for the force of friction, we're going to have to do the sum of the forces in the x. Okay? So those are our forces in the x. Okay? But we're also going to have to solve for our force normal, okay? So, which we have, okay? The question here is, those two do not equal 0. Those two equal mass times acceleration. I guess we didn't really need that, okay? Mass times acceleration in the x, okay? Because that is Newton's second law, F equals ma in that direction, okay? We could do some of the forces in the y. Acceleration in the y, but it's not going through the floor or coming off, so that is 0. Okay, we already know these two numbers, so we don't have to apply that too much. Okay, what we do need to know is mass because of Newton's second law. So let's start way up here. How do we find mass? Well, there's a nice equation that we already know, and that is force of gravity equals mass times acceleration due to gravity. Okay, so that will be our first step. Okay, so now that's going to be equal to the force of gravity divided by acceleration due to gravity, 20 newtons over 9.8. Okay, so our mass is going to equal, should be about 2.04 kilograms. Okay, a lot of students I know were trying to make one of these numbers mass. None of them were grams or kilograms. None of them would work. We have to look for kilograms, and if we don't, we have to look for an equation that will generate that. Okay, all right, so we have mass. So we're going to be able to plug that in. Now we have force applied, we have mass, we have acceleration, we can find the force of friction. Okay, so now we know our mass is 2.04. All right, I'll keep my colors consistent here. My acceleration was 1. Okay, and what else did I know? I knew that my force applied is 30 newtons, and I'm solving for force of friction. Okay, so when we do that, we're going to subtract this over to the other side, and we will get negative 27.96 newtons. Okay, so now we have our mass, we have our force due to friction. We can now plug that in here. Okay, so the force of friction is 27.96 newtons. Okay, when I'm doing this, I'm going to do mu equals force of friction over force normal. I am going to take an absolute value of that because this is going to be a positive. Your coefficient is always a positive number. Okay, so we had our 27.96 newtons over our normal force, 20 newtons, okay, which gives us mu equals 1.4, and that has no units, remember. Okay, all right. So this, by the way, super high number. This is like glue or something. It's a very big number for a coefficient of friction. Okay, so that is our first question. That should set you up for the assignment. Okay, so the assignment looks like this. Notice they ask some questions that I'll look for mu, and then there's questions that looks for acceleration. They never explicitly give you mass, so make sure you focus on gravity to pull your mass out. Okay, all right, so our next question, we're going to look at acceleration, but I'm going to add an additional wrinkle to this process. Okay, so we still have our same equation here, but what happens if we are not on a level ground? Happens all the time. You're on skiing, or you're walking up a hill, or uneven house, or really terrible physics question would be like if an ant is walking over a ball. Okay, a ball is rough because each point is going to have a slightly different slope. Either way, we need to know the slope of the individual at that moment. Okay, so here we have a skier that's starting at rest at the top of the 20-degree slope. He's a show-off, so he skis down the hill backwards. Okay, I found this question online. I just thought it was a nice kind of quirky question. The friction coefficient between his skis and the snow is 0.1. And just like that other type of homework question, I want to find this skier's acceleration. Okay, it's going to be downhill. Okay, now we could set it up in the normal XY coordinate plane. Okay, or this is the new piece. We could change the coordinate plane so that it is now horizontal with the surface. So the question becomes, which of these is an easier mathematical process? The physics is going to stay the same. Gravitational attraction's still there. Newton's laws are still there. Friction's still there. We just want to think about what is going to be easier for us as the person solving the problem. Okay, so let's take a look at some of these choices. Okay, so here we have the different choices, the drawing setup. Okay, so what we see is there is the force of gravity going down, and that is perfectly vertical. The normal force is always perpendicular to the surface, and the friction force always goes opposite of motion, which would have to be going across the surface. We don't have anyone jumping. There's no projectiles in this one. So it's all, this is perpendicular, or this is parallel to the surface. This is perpendicular to the surface. This is independent of the surface. So we have some choices here. We could set it up with our XY coordinate system normal, and then break up the y and the x of this one, and the x and the y of this one, and the x and the y of the acceleration, and keep gravity up and down. and that would give us one way to solve the problem. But we'd have to keep doing trig over and over again. The other option is to take that coordinate system and turn it so that it's parallel to the surface, okay? So if we do that, we just take this and we just turn it. There we go. There we go. Now our xy goes this way. We still have gravity kicking off at this weird angle, but everything else is either all x or all y. And there, we don't have to blend the two or figure out how the trig is going to influence them, okay? So then we can start setting up how are we going to solve this problem, okay? So again, let's look at our basics here. We don't have to bend our algebra like we bend our coordinate system here. Okay, so we want to know acceleration. That is our final goal, okay? So in order to know acceleration, we're going to have to know the sum of the forces in the x, okay? But that means our force applied, okay? If there was one, that's probably going to be 0. Our force of friction, that's going to be mass times acceleration in the x, okay? So again, I'm going back to this picture. I have no applied force. I do have a friction force. I'm looking for acceleration, okay? We don't know this friction number here, right? So if we're going to find this friction number, we're going to have to use this equation, okay? But we keep having to unspool this. In order to find friction, we need to know normal force. We don't know normal force, so we're going to have to find our force in the y, okay? Now I said this was probably going to be a 0, but what do we notice here? Once we turned our coordinate system, we did have some force acting in this new x direction according to gravity. And we have some of gravity's force acting in our new y direction. And that will be equal and opposite to the force normal. So force normal is no longer equal and opposite to all of gravity because some of that is going to translate into motion. Some of it is going to translate into normal force, okay? So now we're going to have our force applied in the y, so this is in the x, and we're going to have our force normal, and then all that is going to equal our mass times acceleration in the y. Now the good news is we finally reached a stopping point, really, is we have this is going to go to 0, which means all of that's going to be 0. So that's some good news, okay? So let's start with our numbers now, okay? So now we can look at our force due to gravity, all right? So we're gonna have our force of gravity equals our mass, which was 75 kilograms, times 9.8. Okay, so that was just m times g. And what do we get for m times g? I think that was 735 newtons, okay? So notice I left a little spot over here because I want to keep my triangles, and I'm going to start writing numbers all over all this stuff here, okay? So we had the force of gravity here was 735 newtons, okay? Now we had this other triangle over here that was at 20 degrees. So now we need to do adjacent, right? Our f of y is adjacent. So we're going to do 735 times adjacent is cosine 20 degrees. Our f of x, that's opposite of the 20, 735 sine of 20 degrees. Okay, so now I can start putting in some of those numbers here. So let's get our calculator here. What were those numbers? So this in our calculator comes out to 690.7 newtons. This one came out to 251.4 newtons. Okay, so our F of y, 690.7 newtons. Okay, it has to add up to 0. So this has to be our negative, okay? Or depending on our drawing system, we can define one as positive and one as negative. I like to make gravity negative and my normal force positive, okay? And all that had to equal 0. All right, so that means we now know F of n must have been 690.7 newtons. Okay, that's nice because that can then come down into here. Okay, so now they told us that mu was 0.1. We just found out our coefficient of friction, or our normal force, multiply it by 0.1. Okay, now we can keep coming along here. That is now this number, 69.07 newtons. And we have our force in the x, 251.4 newtons. Okay, what do we say about friction? Okay, friction always opposes motion, which means this needs to be a negative. Okay, all right. So now we can plug that in again, and we get our new number, which is, I don't know if I wrote down that number. Okay, which is about 182.4 or 0.3 newtons. Okay, so that was our sum of the forces in the x. Okay, so we had 182.4 newtons equals our mass times our acceleration. Okay, our mass was 75 kilograms. Okay, and we're solving for A. We divide both sides by 75. And if I can turn to my right answer here, we should get about 2.4 meters per second squared. Okay, so again, let's think about how do we do this. We wanted to find our acceleration. So we knew due to Newton's second law, acceleration is going to be the sum of the forces in that direction equals ma. Okay, well, in order to find our two forces in that direction, we needed the force from the triangle and we needed the force due to friction. Okay, to find the force of friction, we needed to know force normal. Okay, force normal means we had to add up our forces in the y, okay, and set that equal to mass times acceleration in the y, which happens to be 0. Okay, and then the other thing we had to do in order to find our forces in the y, we had to break apart this drawing. We had to break apart this triangle so that we had our new y component of this leg. Okay, and by the way, you could go through a lot of the geometry. This is perpendicular to each other. We have some bisecting lines. We have some perpendiculars over here. Okay, it all happens to turn out that this angle is always going to be the same as that angle. As long as you draw it carefully and clearly identify your lines, we don't have to do a lot of, well, if this is 90 and this is 70, but this is 90. So if 70 and 90 makes 20, okay, we could get there, but you just know these two angles are going to be the same, okay, which is a nice piece to save us from, so that we can break these two components down, and that gets us finally grounded in a number we know, and then we worked our way back down, okay? All right, so with that, I hope you all have a good evening, and I will see you later.